So by now you've already started by looking at our review quiz for fun, or our review for section 5.1 to 5.3. And I'm not going to do these problems in a specific order, in the specific order that's on the sheet here. What we're going to do is we're going to focus on what is most difficult for today. And we're not going to do this stuff here. We're going to go straight to question number 3 on the second page. Okay, so let's move there right now. Now, the reason why we're doing this question right now and the questions that I have on the second page is that these are the latest things that we studied. And a lot of the times when we do testing for this or assignments for this, we usually have a huge issue with solving these problems. Okay? Now, for this first problem, it says, the path of a projectile can be modeled by the relation y is equal to negative 4.9 t squared plus vt plus h, right? Now, the first thing I want you to recognize is that this is in standard form for our quadratic. So remember, the standard form for a quadratic is y is equal to ax squared plus bx plus c. And if you look at our equation, we have, this is our a value, but we don't have our b and we don't have our c values that we have in our final equation. All right, now let's go over all of the variables, where t is the time in seconds, y is the projectile height, and h is the projectile's initial height in meters, and v is the projectile's initial velocity in meters per second. Now, here is what we know about our equation. We want to find the initial velocity, that's our v, and our initial height. Okay? Now, here is what we know based on our initial equation, right? You know that for every equation, we have a standard form and we have a vertex form, right? And the vertex form is y is equal to a x minus h squared plus k. Now, you'll notice that both of these equations have an a value. The a value in the vertex form and the a value in the standard form are exactly the same. Now, remember they said we're going to calculate the initial velocity and the initial height, right? Now, they also tell us that the maximum height is 50 meters after 3 seconds. So what that tells us is that all of this information tells us that the vertex, which is going to be in seconds, and then after that you have height, is actually just this. Well, 350, based on what we had from before. And we also know that the a value is the same for both. So that means our a value is negative 4.9. So we can come up with the vertex form of a parabola, which is based on this equation. And we're going to rewrite it with the variables that we use for our equation. So you're going to get the following. Y is equal to negative 4.9. Instead of x minus h squared like we have here, we're going to use t, because t is the time that we use. t minus 3 squared plus 50. So now all we have to do is expand. Yes. And based on our expansion, we know that this squared means that this part of our equation must be doubled. So now we're just going to quickly zoom in and make sure we understand what we're doing here. So we're going to end up with the following. Y is equal to negative 4.9, and then t minus 3 plus 50. So now what we're going to do is we're going to take the bracket and we're going to expand it. So we're going to take this and this, multiply it. So you're going to end up with this. Y is equal to negative 4.9, and then you're going to get t squared minus 3t. And then we're going to do the same thing again for the second half of our first equation, of our first bracket. So you're going to get minus 3t again, and then plus 9, because negative 3 times negative 3 is 9. And then we add our 50. So now what I want you to do, in order to cut down on the amount of work that we're going to see, we're going to make sure that we basically simplify the center part of our expansion. That's the one thing we always need to do. So we got to pull those two together. So we got minus 3 and minus 3, which gives us negative 6. And we end up with the following equation. So now we end up with negative 4.9 bracket t squared minus 60 plus 9 plus 50. So now what we have to do is we got to take this minus 4.9, which is sitting in front here, and we're going to apply it to everything in our bracket. And by doing so, you're going to get the following. Negative 4.9 times t squared gives us negative 4.9 t squared. Now, let's go and do negative 4.9 times 6, negative 6t. So a negative times a negative gives us a positive, right? And then we take 4.9 times 6, which gives us 29.4 t. And now we're going to take our 9, our 9 and our negative 4.9. We're going to multiply those together now. So a negative times a positive gives us a negative. And then we end up with 44.1 plus 50. And we just bring that down. And now all we have to do is we have to collect our like terms. So there's only a t squared. There's only one t. So now we just got to bring these two together, which is negative 44.1 plus 50. So you're going to get the following. And this is what we have, but then we must bring these two together to give us 5.9. Now, what exactly does that mean? Okay. All right. So based on what we know, this value here is the start height, also known as the initial height. So you'll hear the term initial height or start height, and that is what our 5.9 is. So that is what our starting height is. So if we were drawing a picture of what's actually happening here, is you've got your chart like so, and here it is. Its starting value when t is 0 is 5.9. Now, remember we said its maximum occurs at 350. So its maximum occurs at 350. Okay. So now this part here is 50. And then if I go down from here, this is 3. And here is the hard part. How do we find another point on our graph? Well, isn't the distance between here and here 3? That means because of our vertex, this is our axis of symmetry, isn't it? Which means a matching point for our graph is exactly 3 meters to the right of our axis of symmetry, which means our next point that is at 5, 9 is going to be at 6, which means our parabola has 3 nice points that we can use to kind of sketch it. So now we have something that looks like this. For our parabola, right? So now the start height or the initial height was basically 5.9. And based on our initial problem that we started with, remember what they said, V times T had something to do with the velocity. The number in front of the T was our velocity, which means our initial velocity was our initial height was 5.9 meters. And our initial velocity is going to be 29.4 meters per second. And we're done. We got all the information we were looking for. Okay? All right, so now let's move on to the rest of the problem set. We're only going to take a couple of minutes to do it because what we're going to do is my favorite thing, which is factoring. All right, so now this is what we just learned today. So now when we're factoring, we're just looking for the number or letter that occurs the most in our factorization. So when I'm looking at this first problem here, A, x squared is equal to 12x, the number or letter that occurs the most is x because I have x squared and x. So I'm just going to pull that off. So you're left with x times, and then you just think x squared divided by x goes into the bracket and you end up with x. And then negative 12 divided by x, when we pull off the x, is just going to be negative 12. So for the next question, we're trying to find, we have x squared plus 11x plus 10. So the key is we're looking for a number that adds to 11 but then multiplies to 10. How are we going to do that? All right, so I need two numbers that multiplies to 10 but adds to 11. And the only ones that tend to work are 1 times 10 gives us 10, but then 1 plus 10 gives us 11. Okay, so then that's what we're going to use. So that means we're going to put our brackets. We're going to put x and x, and then we're literally going to say, okay, 1 plus 10 gives us 11, so we're going to use that. So we're going to go, okay, plus 10 and plus 1, and we're done. Now let's do the same for the next problem, okay? So now we have x squared is equal to 12x and minus 13. So I know there's going to be an x and an x here, but I don't know what two numbers multiply to 13. So for 13, we're going to have a number that multiplies to negative 13, but then adds to positive 12. All right. So now let's go and figure that out. So you know that when we're multiplying to two numbers, we have to have one number that's positive and one number that's negative if we have a negative number on the end here. So let's just try two numbers. So two positive numbers are just 1 and 13. So 1 and 13 multiply to 13, but one of them must be negative. So let's go and choose our negative to be 1. All right, so let's check. Negative 1 times 13 gives us negative 13. Excellent. But now if I take negative 1 and add it to 13, does that give me the middle number? Yes, it does. It gives me negative 12. Negative 13 plus negative 1 gives me negative 12. So you just punch that in your calculator and you're good to go. So this works. So now all we're going to do is we're going to put in minus 1 and positive 13 as our factors, and we are done. So now let's do the same thing for the next problem. So now we're looking for a number on our endpoint here. We've got x squared minus 5x minus 24. So here's the rule. We're looking for a number that multiplies to negative 24 and adds to negative 5. All right, so let's do that. So we need two numbers. One that adds to negative 5, but multiplies to negative 24. All right, here we go. All right, so two numbers that multiply to 24. Let's just go through a bunch of them. So we got 1 and 24. 1 times 24. We got 2 times 12. And then we also have 3 times 8. And we also have 4 times 6. Now, the big hint for you is the middle part here, okay? The middle part of our problem, we know that the end part of our problem, one of them has to be negative, but the middle part is negative, which means the bigger of the two numbers that we have in these columns must always be negative in that case, because we have its overall negative. So that means it's a negative plus a smaller negative number. So let's just go and put the negatives on each one of these, and then we'll just sort of use them to add them up. All right, negative 24 plus 1, nope, that doesn't work. All right, how about negative 12 plus 2? Does that give me the middle number of negative 5? No, it doesn't. I'm going to cross that off. All right, how about 3 plus negative 8? Oh, my goodness. It works. So now we write our x brackets, and then we're going to put positive 3 and negative 8 as our final answers. Okay, so now let's go and do the next set of problems here. So here we go. We've got x squared minus 12x plus 36. So that means we're looking for a number that adds to negative 12, but times to positive 36, right? So I'm going to tell you that we have a bunch of possibilities again. We have 36, 1, and 36, right? Notice how I'm putting a space between my x's and my 1's. Then I have 2 and 18. We have 3 and 12. And we also have 4 and 9. And we also have 6 and 6. All right, so here is what we know. We know that in order to get positive 36, we either have two negative numbers or two positive numbers, right? Now, I'm going to tell you right away that we have two negative numbers, and I'll tell you why that is. The reason why that is because we have a negative answer at the end. So because we have we either have two positive or negatives, but then we have a negative in the middle, it means that we both have negatives for each one of the numbers in our possible multiplication. So I'm just going to quickly put those in. And now all we have to do is go through all the possibilities. Well, so now we're going to go, all those numbers multiply to 36, yeah? Positive 36. So now all we have to do is just add the numbers. 1 times 1 plus 36, -1 plus -36 doesn't work. This one doesn't work. This one doesn't work. This one doesn't work, but this last one does, because we have -6 plus -6 gives us our -12. Perfect. So now all we have to do is write our brackets with x. And now we have x minus 6 and x minus 6. Good to go. All right. Now this last problem is a difference of squares. You notice how we have x squared and then we have 49. The key is to remember that when we have a difference of squares, we have the square root of x squared is just x, right? And then the square root of 49 is equal to 7. So that means when we have two perfect squares like that, and we have a subtraction in between, all we have to do is rewrite x and x, and we have -7 and +7, and we're done. Now, let's take a look at this last problem of the day. So, your job today, it says, write a factored expression of the area of the region. Okay, so if you look at this region, right, we have x and x, right? So the big area is x squared. So let's call this A big. A big is equal to x squared, right? It's just x times x, right? Now, each of those little blocks in the middle there, the small blocks, A small, are, well, each of them are 4 centimeters squared, right? But if you look at them, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So we need to take 9 times 4 of them, which gives us the following answer. It gives us 9 times 4 is 36, right? So here is the rule. So the area of the overall thing here is the area of the big minus the area of the small, right? Now, we identified the area of the big to be x squared and the area of the small to be 36. So let's write that in. So we have the area of the overall thing being x squared minus 36. So now let's continue. It says, find a factored expression for the area of the shaded region. So the area of the shaded region is this. In order to factor it, what we're going to do is we're going to imagine that we're just looking at it. A is equal to x squared minus 36. Now, if you look at our previous problem that we have here, okay, the previous problem that we worked on up here, x squared minus 49, you'll notice that we have the same situation happening for this. We have a perfect square for x squared, and, well, you know the square root of 36 is 6, right? So here is our answer. We're literally just going to write 2 brackets. So the square root of x squared is x, but then the square root of 36, punch that in your calculator, you get 6, right? And since it's a difference of squares, we write plus 6 and minus 6 for our answer. So there we go. So that is our final answer, and we're done. Now, your job for today is to work on these questions here, okay? Because it's very similar to what we have prepared lately, all right? So I want you to remember to do these questions and give yourself extra time to understand how to factor, okay? So make sure you work on those questions first, and then tomorrow we'll go and work on the earlier stuff that we did in the unit, which will be on page 1.